Welcome back, ladies and gents, for this fifth and second to last video on limits. Uh, what should we take a look at? Maybe a very quick review of what we have seen last time. You remember that we saw that the limit as x approaches 0 from the right side of 1 over x actually gave us plus infinity, and that the limit as x approaches the same 0 but from the left side, that gave us minus infinity. From that, we got that if we cheat into this limit, that is, if we replace 0 into the function, we get that 1 over 0 plus is the same thing as infinity. And if we cheat on this one as well, 1 over 0 minus, that is the same thing as minus infinity. You may remember why. It's because the graph of 1 over x is actually shaped that way. And as 1 approaches 0 from the right side, well, where's the y value? It's way up there, and it actually shoots towards positive infinity. And if I approach 0 from the left side, then the y value is over here, and it tends to go towards negative infinity because the y-axis is an asymptote, so the graph never connects. It only gets closer and closer and closer, but it actually never touches. Good. So that's what we saw last time. So we can sort of kind of link this to what we want to do today. Today, I would like to look at a subchapter of limits that's called limits at infinity. How is this different than what we have just seen? Well, when the outcome of a limit is infinity, we have what's called an infinite limit. Now, what I want to do with this is actually, I want to take the limit as x approaches infinity and to stay in the spirit of things. And since we have the graph of that function, why don't we take that limit of that very function? What is that equal to? Equals what? Well, from the graph, I want to know what's the y value being approached when x is actually very, very large. So x is going way, way this way. It's clear that the graph actually is going to approach what y value? What is this y value that we're trying to approach? 0. Right? Now, if we actually approach negative infinity with our x's, what is going to be the y value being approached from the graph? Well, this time we want to actually be very, 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 very far this way. So the graph is going to be, because it's a horizontal asymptote, getting closer and closer and closer to what y value? 0, of course. So what does that mean? It means that, again, if we cheat on this thing, that is, if we replace x with infinity, we get that 1 over infinity is 0. And if we cheat on this guy, we get that 1 over negative infinity is 0, which actually gives us a very good overview of certain very important quantities in this chapter. And we could already have a mini summary of the late events in this chapter. What is that summary? Well, we have this. We have three things really. we have that 1 over 0 plus, what is that? 1 over 0 plus. Of course, it's infinity. We also have that 1 over 0 minus, what is that? That is minus infinity. And now, again, because of the graph of 1 over x, which is extremely revealing for these limits, we have that 1 over either plus or minus infinity. It's the same answer to both. And the answer is 0. So that is an interesting kind of little connection between the infinitely large and the infinitely small, right? At least in the sense of something close to 0 being infinitely small, right? Good. So let's explore this some more. I'm going to erase this now. So if you want to make a pause, now is a good time. Okie dokie. Well, as usual, the best way to explore this is through examples. So example 1, evaluate, let's see, limit as x approaches, let's say, infinity. We can also take a look at negative infinity later, of x plus 1 over x minus 1. Okay. That function is not an easy function to graph, so I turned to an online graphing tool. I like Desmos, I don't know if you do, and I actually got this graph for this function. So this is going to be the graph of the function x plus 1 over x minus 1. And the way it goes is like this. It has a vertical asymptote at 1. As well, it has a horizontal asymptote also at 1. Like this. And the shape of the graph is actually something like that. It should actually remind us very, very much of the graph of 1 over x, but it's actually shaped a little bit differently. So this is the graph of y equals x plus 1 over x minus 1. I should label my axes to be kosher. So y plus 1 over x minus 1. And here we are. So it's probably the best way to evaluate this limit is probably to look at the graph, because if I were to do this numerically, then, I could do it. I could build a table with values of x larger and larger, like 10,000, 1 million, 1 trillion, and eventually I would figure out what is the outcome of this. The graph might be a little more revealing. So let x be really, really large. So x goes really, really far this way. What is the y value being approached by the graph? Well, as you look here, if you're here, that's the y value. If you're here, that's the y value. And if you're there, that's the y value. So these y values getting closer and closer to the horizontal asymptote. So from this, I can tell from the graph, the limit as x goes to infinity of x plus 1 over x minus 1 is actually equal to the horizontal asymptote 1, right? So if you have the graph, it's not very difficult to read the answer to this. What I would like to explore with you is an alternate way to actually not do this using the graph, perhaps looking at an algebraically approach, or just algebraic approach. My English is not really the best. Okay, so how do I do this algebraically? Well, The algebraic method usually tells us that we have to use algebra. And before we do that, we usually perform something we call a cheat. Remember, we can do this because we have rules about separating the limit up and down and then breaking the limit to x and the limit to the constant and so on and so forth. So a cheat here would be what? Infinity plus 1. It's infinity. Infinity minus 1. If you take 1 away from infinity, not going to change much to the fact that it's the largest thing in the universe. What is that? If you're tempted to say, well, I can cancel the infinities and it'll give me 1, I would actually bring your attention to the 0 over 0 we saw earlier. Are we allowed to cancel 0 and 0 to give us 1? No, we're not. So in the same fashion, we cannot cancel infinity and infinity. And do you know why? Because infinity is, you ready for this? Indeterminate. Oh Lord, another indetermination. Also known as undetermined. Yep. Undetermined or indeterminate. Fortunately, the way to deal with this is actually quite easy. Whenever we have this, so whenever we have infinity over infinity, and that may also apply to infinity over minus infinity or minus infinity over infinity. Signs here don't change our approach. If we have that, we use the following technique. So divide top and bottom. That's a short way to say numerator and denominator. By x to the highest power in the entire expression. In the entire expression. Well, let's see what actually this gives us. Bon. Well, let's see if I apply that to my situation. What will I get? Look at this limit. What is the highest power of x you can actually find in here? It's x to the 1 top and x to the 1 at the bottom. So clearly, limit as x approaches infinity of x plus 1 over x minus 1 is the same thing as limit as x approaches infinity of, like I'm going to follow this guideline. I'm going to divide the top by x to the 1. I'm going to divide the top by x to the 1. And I'm going to divide the bottom as well by x to the 1. Okay? Now, I'm going to do a little bit of algebra. After all, it's the algebraic method. So what is this? It's the limit as x goes to infinity of what? Let's break this up. This is x over x plus 1 over x, right? I can give the denominator to each of the elements in the numerator. This is x over x minus 1 over x. This is then the limit. I painted myself in a corner here. Will I have enough room to finish this problem? X over x is 1 plus 1 over x, 1 minus 1 over x time. To cheat one last time, replace x by infinity. 1 plus 1 over infinity, 1 minus 1 over infinity. We just saw that 1 over infinity is what? What's 1 over infinity? You said 0. Very good. 1 plus 0 over 1 minus 0. Final answer, 1. I did paint myself in a corner here. And of course, it's the same answer we got from the graph and its horizontal asymptote. So that's a good technique. Divide top and bottom by x to the highest power in the entire expression. whenever you are facing infinity over infinity, give or take a positive or a negative sign. All right, let's do another example. Let's get rid of this. All right. Exemple 2. What is example 2? What if we wanted to take the limit as x approaches infinity, again, of a good old polynomial like x squared plus x minus 1 over something like 3x3 plus, I don't know, x2 minus 4. Okay, good old limit. So just to be on the safe side, I'm going to start this with a good old cheat, and I'm going to get infinity squared plus infinity minus 1 over 3 times infinity cubed plus infinity squared minus 4. Infinity squared, so the largest number times the largest number is the largest number. The largest number plus the largest number is the largest number. The largest number minus 1 is the largest number. The largest number cubed is the largest number. The largest number times 3 is the largest number. The largest number plus the largest number squared is the largest number. Minus 4 is infinity. Okay, fun things under the horizon in the minute. But now we have a strategy for this, don't we? We're going to divide top and bottom by x to the highest power we can find anywhere in here. What is the highest power you can actually spot in this expression? If you said 3, you're right. So this is the limit as x approaches infinity of x squared plus x minus 1 over x3. That's the largest expression in the entire, our largest power, in the entire expression. And that's 3x3 plus x2 minus 4 all over x3. Okay, so now we distribute that common denominator. We distribute that to each. So I'm going to get x squared over x3. I'm going to get x over x3 minus 1 over x3. All that jazz, 3x3 over x3 and x2 over x3 minus 4 over x3. I'm going to try to see if I can cancel some of these expressions. x2 over x3, x over x cubed. That last one does not cancel. 3x3 over x3 is 3. x2 over x3 is 1 over x. And minus 4 over x3 stays what it was. Good. It's time to cheat again. We're replacing the limit into this, and we get 1 over infinity plus 1 over infinity squared minus 1 over infinity cubed all over 3 plus 1 over infinity minus 4 over infinity cubed. What's all this? 1 over infinity. 1 over infinity squared, which is infinity. Infinity cubed, 1 over infinity cubed is 1 over infinity. It is 0 over 3 plus, that's another 0. That's another 0. Look at that. 0 over 3. Does that exist? For sure it does. The answer to this limit is 0. Good. Erasing in 3, 2, 1. Let us do another example. Example numéro 3. All right, what is example numéro 3? Let us do this time the limit. Let's change infinity to minus infinity. So it's a little different. X approaches minus infinity. And let's take a function, something that actually is going to have a bit of a weird behavior. 1 minus x squared over 1 plus x. Well, the way we do limits, what is the first thing we do? Pretty much all the time. We cheat, we replace whatever x is approaching into this. So that is 1 minus infinity squared over 1 plus minus infinity. Yo, what's minus infinity squared? It's infinity. 1 minus infinity, moins infini. 1 minus infinity, minus infinity. The signs, we don't really care. This is infinity over infinity, and we know what that means. It's indeterminate. What does indeterminate means? It means we cannot leave the answer like this. We got to do extra work to figure out what this limit is. What is this extra work? Well, we're simply going to divide top and bottom by x to the highest power, because that's what we do when we have infinity over infinity. So this limit will now be equal to the following limit. Highest power in the entire expression is 2. So 1 minus x squared shall be divided by x to the 2. And the bottom, 1 plus x, shall also be divided by x squared. So we do our thing. We separate and simplify. 1 over x squared and minus x squared over x squared. That's what I get for the numerator. Denominator 1 over x squared plus x over x squared. All this will neatly simplify to what? 1 over x squared minus 1 over x squared plus 1 over x. Time for one last cheat in this problem. So replacing x with negative infinity. Minus 1 over infinity squared plus 1 over infinity. That should be a squared. It looks like a 2. Let's do this right. All right. Minus infinity squared is infinity. 1 over infinity is 0. 1 over infinity squared. Well, infinity squared is infinity. 1 over infinity is 0 plus 0. What is that? Minus 1 over 0. What is that? That is D and E. This does not exist, or undefined. Undefined is another name for this limit. Okay, we're starting to get a drift of this technique. So let's do one last problem in 3, 2, 1. All right. So I kept the nicest one for the end. Example 4. Evaluate the limit as x approaches infinity. I'd like to put some sort of like a little bit of difficulty into this one. So I will introduce a square root. So this is x over the root of 4 plus x squared. By now, you know how the algebraic method begins. How does it begin? If you said cheat, then you're learning something, definitely. Putting infinity in the place of x. Infinity over the root of 4 plus infinity squared. That's infinity over, what's infinity squared? And infinity plus 4 is infinity. Root of infinity is infinity. Indeterminate again. So, I'm going to divide top and bottom by what? X to the highest power. But let's be careful here. What is the highest power of x in here? X to the 1 on top. I do have an x squared here, but this x squared is what? It's actually into the square root. So the highest power of x here is not x squared. It's the square root of x squared, which is x. So this is the limit as x goes to infinity of x over the highest power of x in this expression is x. Divided by the root of 4 plus x squared, also divided by x. All right. What is this? What is this animal? This is, the numerator is pretty straightforward. X over x is going to be 1. Now, this here is quite tricky, actually. What is it that I have here? Because if I replace x by infinity into here, I'm still going to have something that I don't like. I'm still going to have infinity over infinity. I need to find a way to handle this. Here's what I suggest. This is going to be the root of 4 plus x squared over x. And I suggest that from within this root, we actually do something a little awkward. We factor out x squared from 4 plus x squared. What will I get if I do that? I'm going to get, well, there's no x squared here, right? So it's going to be 4. I need to give myself a little more room here. So it's going to be 4 over x squared. And then I'm going to have plus x squared over x squared. Then I can actually close my root on all this. Why that? It may not be obvious why I'm doing this right now, but there is a reason. There's always a reason behind these moves. So that is 1 over. Okay, recall. Let's go aside for 1 second. We've seen that in high school. We've seen that in the review videos. Recall. The square root of x squared is x. If x is positive, right? And it's minus x if x is negative. So basically, x is approaching infinity is a very, very positive value. So I can actually write this as, I got too many markers in my hands. I can write this as the root of x squared times the root of 4 over x squared plus 1. All of that over x. And now I got a very nice simplification because the root of x squared, which is x, will cancel with the x here. So that I find myself with the limit as x approaches infinity of simply this. 4 over x squared plus 1. And I'm ready to actually do the final cheat. Replacing by infinity, I'm running out of space again in the corner, so we'll just basically cut to the chase. 4 over infinity squared. What's infinity squared? It's infinity. 4 over infinity is 0. So 0 plus 1. Agreed? So basically, the answer is 1 over the root of 1, and the answer is 1. And voila, that's the answer to this problem, which concludes this session on limits. We have one more to go through, and we'll be ready to move on to the next chapter. All right, so I'll see you soon on to the next one. Have a good one.